This example shows a 3D retention model of a mixture of 12 aromatic compounds, which are listed in this table. The front face of the resolution cube is a gradient time versus temperature plane, the same plane that is shown on the left-hand side resolution map. It is possible to move the cursor to any position within this plane. The lower chromatogram shows instantly the predicted separation. Regions colored red indicate higher resolution, where peaks are baseline separated, whereas blue regions indicate areas where peaks co-elute. Rotating the cube 90 degrees to the right, we see the third dimension of the separation, which could be either ternary composition or pH. In this example, the third dimension is the ternary composition, with the label %TC referring to the percentage of methanol in acetonitrile. The cube can be tilted and rotated 360 degrees. In this way, all 6 exterior surfaces can be examined. The front of the cube, showing the gradient time versus temperature plane, is the reference position, and it is possible to travel through the cube and view the successive layers of gradient time versus temperature planes for the different ternary compositions. In this way, it becomes easier to visualize the continuous regions of high resolution that extend into the cube and are bounded by areas of low resolution. Right-clicking on the cube, one can alter the cube image to show only these regions of high resolution. Once isolated, these 3D volumes of robust working space make it easier to select the working conditions that will offer the best tolerance to perturbations such as temperature fluctuations and pH drift. Once these robust conditions have been selected, the separation can be further optimized in the gradient editor. In this example, the starting percentage of B could be increased to decrease the retention time of all of the peaks. Next, a second gradient point can be introduced. By increasing the slope of this second gradient segment, we can decrease the retention time of the last group of 3 peaks. By making these simple adjustments, we have already removed 5 minutes from the retention time. Further changes could be made in the column parameters section, where changes to the column length, diameter, and particle size can be mimicked, as well as changes to the flow rate.